Okay, so I'm going to start on this one midstream on this problem. I've got in here, I've labeled in here, like the half-life is 4.20. I've got the A naught, which is the 5.00 times 1022 atoms. And I want to find out how many atoms I have after 42 minutes. Okay. I went ahead and did my half-life. So using T half equals 0.693 over K. I rearranged to get K on the other side, which ends up being 0.693 over 4.20. That equals my K. And I got my number for K. Once I have that, then I'm going to go back to my equation, and which is the natural log of A naught over AT equals negative KT. And so I'm going to go back to your notes to make sure this is clear. This is what I'm using right here on the first order, and that's how I rearrange it into the natural log AT minus natural log A naught. It has to do with natural log rules. And it's negative KT. Now, I'm fixing to pull up my calculator and I'll show you how much of a difference this makes depending on what you're doing with it. So I've gotten down here to this natural log AT equals natural log 5.00 E22 atoms equals negative 0.165 times 42. Now, I hope you can see what I have here. I don't know. Yeah, okay, I can scroll. All right. So I went ahead and I put in the negative 0.165 times 42 and then a positive 0.165 times 42. So I treat it as if on one you're doing it right and on one you forgot the negative, because I want to show you how much of a difference that would make on this problem. So here I go through and I'm using the positive number first, and I do the 6.93 plus log natural log 5.00 E22, and I get a 59.19. And then when I do the inverse natural log, that answer, I get 5.11 E25. Now, as soon as I hit that number, I know that I've done something wrong, because if I started with 5.00 times 1022 atoms, and I'm doing a radioactive decay, I can't have more atoms than what I started with. Okay, so that's your first sign something's not right. So go back and check to see if you did the negative. Once I do the negative, I'm going to end up producing a much better number. I get a 45.33. I do the inverse of that, and I get 4.89 e to the 19th. And that is a reasonable number, and that is the correct answer. So I wanted to show you what the difference between the negative and the non-negative was on the number itself.